an extension to evaluating functions at points is evaluating what we call the difference quotient. And we're actually going to derive the difference quotient in one of our next sections, but it's basically f of x plus h minus f of x over h, where I want to evaluate various functions at these points and then simplify the equation. The first example of difference quotient type evaluation I'm going to do is where f of x equals x squared minus x plus 1. And instead of having the x plus h, I've got a 2 plus h here because I'm evaluating this difference quotient at the point x equals 2. So, just like evaluating functions where I have f of 2 plus h, what that means is put a 2 plus h everywhere that there's an x in my original equation. So I'm going to write 2 plus h quantity squared minus 2 plus h plus 1 minus my original function with a 2 substituted in there. So I'm going to put brackets because it's minus the whole thing. Minus 2 squared minus 2 plus 1 all over h. Then what I want to do is I want to simplify the numerator. 2 plus h quantity squared is 4 plus 2h, actually 4 plus 4h plus h squared minus 2 minus h plus 1. 2 squared is 4. 4 minus 2 is 2. 2 plus 1 is 3. With a negative in front of it is negative 3 over h. And now let's simplify and write the numerator in standard form. I only have one h squared term, so it's h squared. I'm going to just cross it off in red so I know I've used it. For h's, I have 4 h's minus an h, which would give me 3 h's. And for my numbers, I have 4 minus 2, which is 2, plus 1, which is 3, minus 3, which is 0, all over h. Every term has an h in it, so I'm going to divide everything by h. H squared divided by h is h. 3h divided by h is 3. So the final answer to that problem is h plus 3. The next question is to evaluate x cubed plus 3x using the difference quotient. Again, everywhere there's an x, I'm going to replace it with an x plus h. So I have x plus h cubed plus 3 times x plus h minus my original function. So minus x cubed minus 3x all over h. I'm going to use the binomial theorem to write the first term, which is x cubed plus 3x squared h plus 3xh squared plus h cubed. And need to fix that. That's supposed to have been an h. Plus 3x plus 3h minus x cubed minus 3x. And again, this is all over h. Going to write it in standard form. I'm going to start out with my x cubes. I have an x cubed and a negative x cubed. Those cancel. I have a 3x and a negative 3x. Those cancel. And it looks like every term that's left is going to be here. So let's write this down. I have 3x squared h plus 3xh squared plus h cubed plus 3h all over h. Notice that every term in here has an h, so I'm going to divide every term by h, and my final answer will be 3x squared plus 3xh plus h squared plus 3.